Hello people, welcome back to the Anime 101 course. Through this tutorial, 7th part, we will start dealing with particle systems by using real-life physics laws, especially using Newton's second law of motion. If you're not familiar with this one. Force equals mass times acceleration. What does this mean? The force of an object will be proportional to its mass by its acceleration. We will use this second law of motion in order to create particle systems which actually react to real life physics. So let's get started. First I will create a point. Set one point. We'll create multiple points. And I need to create Newton's second law of motion variables, which are mass and acceleration and force. So I will create the mass of the objects. I will make it randomly at the moment. I need to have the same number of masses as points, so I will create a random list and build a domain. So masses will go from I'll go from 0.7 to 1. This will be my masses. This is the masses. I need to set the acceleration, the global acceleration of the system, not the acceleration of the force equals mass times acceleration. So I will go for 1. 1. This is the global acceleration, which will be a multiplier of my forces. And finally, I need to create the translation vector, which can be actually 1 for all of them. There we go. After that, we need to calculate Newton's second law of motion, which we said it was force equals mass times acceleration. We already have the force, which is our vector, we have the mass, but we don't know the specific acceleration for each particle according to its mass. So we need to calculate acceleration equals force divided by mass. This is what we need to do in order to implement the Newton's second law of motion. So let's write this function using an evaluate. So the length of the force will be divided by its mass, and after we've done that, we will reset the unit vector of our force to our new acceleration. So they will multiply this by the unitized force. There we go. We need to rename these variables. We'll call this force. We'll call this mass. So we got the force, which is this one, we got the masses, and there we go. We'll turn this off. This is actually Newton's second law of motion. Next, we need to set up our loop. So let's go to Anime, bring loop start and loop end, as usual. We need a new input, which is this one. I will record the data as well. So data will be the points, and the one will be the vector. What I need to do now is to multiply the acceleration for each point on our, multiply it by the global acceleration, which is a multiplier, which we can control the acceleration of the vector along our loop. So let's calculate the length of the vector, and we will multiply it by our global acceleration, and we need to amplify the vector by the result. So this is the motion vector. So I will move my points using this vector. There we go. After that, we need to introduce the data into a loop. This is the point, the geometry, and this is the translation vector. And if I iterate, say, 50 times, there we go. You can tell the accelerations are actually different because they depend on the mass. I will use a button. If I decrease the global acceleration, every frame, every iteration, the acceleration will go slower, so it will stop eventually. It's like a damper. This is the basic concept on using particle systems, and we can actually implement this logic with any sort of forces we want. We'll call this is the translation vector. We will create another one, which will be, say, a wind force. For the wind, we need to recalculate as well Newton's second law of motion. There we go. Let's add a new input, the new output. We'll return this to 0, so we won't have any problems. We'll introduce the wind vector. And the wind vector, well, we need to define it as a unit vector on x, for example. Next, we need to recalculate the wind vector. So let's calculate the vector length of the wind. We will multiply it by the acceleration. We want the acceleration of the wind random every frame. As it happens in real life, it keeps changing all the time. So let's create random, which will be the same for all the vectors. The state will be changing according to the counter, so it varies along the loop, and we will create a domain. Subdomain. Only needs one value. There we go. We will go from -10 to 0. We'll go to -5 to 10.0. We'll go to 10 or whatever you want. There we go. So this is the acceleration of the wind. So we need to reamplify the wind, which is this vector. This vector by our acceleration, which is random every frame. We'll move this. What I need to do is to add to sum the vectors, the translation vector and the wind vector. This will be actually the final vector of movement. There you go, you can tell it's different. And the input of the loop end will be not the amplified vector of wind. We need the unit vector. So we always reamplify based on a unit vector of wind. We don't care about the magnitude of this vector. The translation vector, we will replace this to the result of all the sum of the vectors. We'll turn this off and let's loop. Well, it's a way huge wind force. I will go to -0.5 to 0.5. I will loop again. And I will return my acceleration to 1. There you go. This force is being affected by a wind force, and it works pretty well actually. So basically that's it. This is the particle system using real life physics. Thank you all for tuning in, and on the next tutorial we'll start using particle systems to create more complex behaviors, like swarming for example. Thank you all and see you next time.